In this video, we will be discussing rounding with Python, starting with the built-in round function, then going through some of the different functions that we can use from Python's math module, including getting the ceiling of a number, the quote-unquote floor of a number, and truncating a number. And don't worry, we will cover what all of that means. But first things first, let's talk about the round function that Python gives us built in without needing to import anything. All you have to do is type round, which is the name of the built-in function, then parentheses, which we do when we're using a function, and then you can write either one or two values here inside the parentheses. So let's start with just writing one value and see what happens, and let's do 3.8. And of course, we'll need to print it, so let's print. So now what's this doing? Well, we're going to see what round 3.8 does, and then we're going to print that. And it prints a 4. So what's going on here? Well, as you might have guessed, we are rounding 3.8 to the nearest integer. In this case, the 0.8 at the end means it's closer to 4 than it is to 3, so it gives us 4. If we were to do something that's closer to 3, say 3.3, and then round that, it will print out 3. Well, what about 3.5? 3.5, it's right in the middle. It's not closer to 3 or to 4, it's right in between. And will that round up or will it round down? Well, this is interesting. Many of you probably learned in school, as I did, that when you round something at a half, it always rounds up. Every single time, if you say, I want to round 3.5, it'll round up. If I want to round 4.5, it'll round up. So you might think Python's following that rule that you learned in school to always round up whenever you're trying to round a number that ends in a half or a 0.5. Well, let's see what happens when we do 3.5. Will it round up to 4? Oops. Will it round up to 4? It does. Okay, so everything's hunky-dory, just like we learned in school. You just round up at half, right? Let's see. Let's try again. And this time, let's do 4.5. So if we print round 4.5, it also gives us 4. Okay, well, it's also giving us 4. Well, it seems like it's rounding down 4.5, but when we rounded 3.5, it rounded to 4, and we round 4.5, it rounds to 4. Well, what's going on here? As the saying goes, it's not a bug, it's a feature. And in this case, it is the result of a deliberate choice. In Python, when you have a number that's halfway, it rounds to the nearest even result. And I'll say that again, it rounds to the nearest even result. And that's only when we're dealing with a 0.5, mind you. And normally, it just asks, hey, what's the closest integer? And it spits out the closest integer. But when your computer is told to round 3.5, you could think of it as asking, hey, is this closer to 4 or to 2? Well, it's closer to 4, of course, and so it gives you a 4. But when your computer is told to round 4.5, you can think of it as asking, is this closer to 4 or to 6? And then it gives you 4 again. Well, why go through all that rigmarole? Python uses, and this is Python 3 in particular, uses a different rounding method than the one you probably learned in school, but one that a lot of people out there prefer, or at least think is better for computing, called banker's rounding or Dutch rounding. And the general thinking is that when you're rounding a very large amount of data, and you always round up at 0.5, so every time it hits that even in the middle point, and it's always like 4.5, 3.5, 2.5, 7.5, 100.5, and you're always rounding up, rounding up, rounding up, then your data is going to start drifting away from where it really should be. So in the data set, if you're always rounding up to the nearest even, if you're always rounding up rather, then you'll be rounding up and up, and you'll be what's called biased towards a positive infinity. And the same would be true if you were always rounding down, right? But if you are rounding to the nearest even number, then what's happening? Well, the result is you're rounding 0.5 values up half the time, and the other half of the time you're rounding 0.5 values down, so that'll even out any drift in the data. There won't be any bias towards making the data too high or too low. So just to recap, let's go to the console and see some of these examples. If we round 4.5, well, that rounds down to 4. But if we round 5.5, that rounds up to 6. And that's just because it's rounding to the nearest even integer rather than to the nearest integer. Okay, so what if you wanted to have rounding work the way you learned in school and always have zero point 0.5 values always round up? There's no easy ready-made function. There are a couple of things that might work for you depending on what you're doing, and we'll cover a couple of those ideas when we discuss ceiling and truncate later in this video, so stay tuned for that. There are better solutions out there as well, in addition to the ones that we'll talk about later, from people who wrote their own functions using the decimal module or otherwise. So it's certainly something that you can explore on your own. But before we get to any of that, let's wrap up what we can do with the round function. Remember that I told you you can either put 1 or 2 values inside of these parentheses. The first value here, say 5.53 and change, is what you want to round. That's the float of what you want to round, okay? And then the second value, that's the number of digits after the decimal that you want to get. So say you wanted this value to 3 digits, and there it is, rounded to 3 digits. Okay, so let's do another example here. Say you wanted to round 3.14159, and say you only wanted that to 2 digits. Okay, so you type round, parentheses, the first number that you want to round, that's that 3.14159, comma, and then the second number is the number of digits after the decimal that you want this to go to. And there it is, 3.14, delicious pie. Okay. And instead of doing the second number, what are some other things you can do? You could write the word none with a capital N. So let's try that, 3.14159, and then with a comma, and then none, N-O-N-E. Note there's a capital N there. And what happens there? You get a lone 3. Well, what's going on? Really quickly, what is this? What is none? Well, perhaps a subject for a future video, but just to show you, let's take the type of none and see what it is. It is none type. It's being into itself. It's not the same thing as 0. If you were to do the same thing with 0, 14159, 0, it's not going to give you the same thing that happened with none. It actually gives you 3.0 because you're saying, hey, I want 0 after the decimal. And so it's its own thing. Okay, and another example of this, what's the type of round, say just 5.99, none. Okay, so what's this asking? Well, we're asking, hey, do this function of rounding 5.99 to none, and then what's the type that it gives you? That gives you an integer versus type round 5.99. Oops, 5.99. Say you just want it to 1 decimal. That gives you a float, and it'll be the same for 0. If you type round 5.99 to 0, it will also give you a float. Okay, the last couple of cool things with rounding, you can use an expression instead of a value for this first value. So say you want to do round 4 divided by 7, comma 3. Okay, well, this is actually going to give you something. It gives you this. Well, what is happening here? Well, first, the computer takes 4 divided by 7, okay, which, as you see, is this long string of numbers. And then it says, okay, well, we're going to round this to 3 decimals. And indeed, as you saw, it did. It gave you 0.571, which is this, to 3 decimals. You can also use the constants that math gave you, and if you're not familiar with these, you can check out my prior video on the constants. So if you wanted to round pi, as you might remember, first you import math, then you have math.pi, which gives you an approximation of pi, as you might remember. So instead of writing all this out, if you just wanted to round it, you can round math.pi, and say you wanted to do 2 digits, it'll give you 3.14. Say you just wanted to do round math.pi into just one integer, and it'll, of course, round down to 3. Okay, so what type of data is a rounded number? As you saw, it is a float when you have these digits. But what is it if you're just rounding, to one digit here, one single digit with no decimal? We can do math.pi again, and let's take its type. And as you see, it is indeed an integer. Okay, well, you might be thinking, why don't I just convert something to an integer? Instead of going through this whole round process, I can just convert to an integer by doing int parentheses. Well, let's try that. Integer of 3.22 gives you 3. Oh, okay, that rounded it to an integer. What about integer of 3.99999? Which you would think if we were rounding, that would round up. So let's see what happens if we just convert it to an integer. No, it still rounds down and converts it to the lower integer back to 3. Basically, what the integer function here is doing is it's just chopping off all the decimals and then turning your float into that integer. So it's great and all, but it's not really going to round it for you. If you want to round, you can use the round. And so if you do round 3.99999, and that'll of course round it up to 4. Another comparison you can make is that this integer function is truncating. It's chopping off all the decimals. It's very similar to the truncate function in the math module that we'll discuss later. Also, if you're rounding with more decimal places, of course, it's not going to give you the type integer. It'll give you the type float, as we just mentioned. And a couple other quick things. Can you round infinity? As you might recall, to represent infinity, you can do math.inf, which we discuss in detail in my previous video. You cannot. You get an overflow error. Basically, the computer's telling you, hey, that's too much. And fair enough. And what about not a number, which also is discussed in my previous video? Can you round the float value for what's not a number? You cannot. It's not a number. You can't round it. Okay, and that's rounding using just the inbuilt round function without the needing to use the math module to round things. How can we use this math module to do other kinds of rounding? Well, let's talk ceiling, floor, and then truncating. Let's start with ceiling. So get rid of this. And if you remember, integers can be positive, they can be negative, be 0, they can't be a decimal. Each of these things, ceiling, floor, and truncating, they'll only give you an integer. They're not going to give you a number followed by a decimal point, followed by more numbers like round could. They're only going to give you integers. And let's import math. Ceiling gives you the smallest integer that's greater than or equal to the value given. And I know that's a mouthful, but practically speaking, you can think of it as telling your computer to round up to the next highest integer. Okay, so I'll give you an example. This one is math.ceil 7.1. Okay, and we'll print it. If you were to just round 7.1, it would round down. It's closer to 7 than it is to 8. But if you're looking for the ceiling, let's see what happens. It gives you 8. It rounds up to the next highest integer. Let's try it with 7.9, which is, of course, also going to give you 8. And then, just for good measure, we'll try it just with 8, just to see what happens. And it's still 8. It's not going to boost it up to 9 or anything. If you're feed it an integer, it'll just return that same integer. Okay, well, what about with negative numbers? And here's where things get a little bit tricky. You might recall from school the number line, so -5, -4, -3, etc. Here's a basic number line of integers, and you see everything after the 0 trends towards positive infinity. It's going to a greater value. And as you go to the left, then you're trending towards negative infinity, and you're getting a lesser value. Okay, well, if you were to do math.ceil of negative 2.99, where is negative 2.99 on our number line? It's right here. It's just after -3. What's going to happen? Is it going to give you a -2 or a -3? It gives you a -2. And that makes sense, because remember, when you're dealing with negative numbers, -2 has a greater value than -3. It's closer to positive infinity than -3 is. And so it's a greater number, so if you're looking for the ceiling, it's going to trend to the right on your number line. For good measure, let's check the let's go back to our console, and let's check the type of value we're getting when we do a ceiling. So type math.ceil of some number, and of course it is an integer. So earlier in the video, I promised to show you a couple of ways that you can round up when you're stuck with this 0.5 value, which the Python round function only does half of the time. But if, say, you always wanted to round it up, well, here's one way. If you remember, if you do round 7.5, that should give you 8. Okay, whoops. That should give you 8. Okay. But if you do 6.5, well, that brings you down to 6. Okay. Well, how do you do it so that it's always going to bring you up to 7 when you do 6.5? Well, you can, instead of rounding, you can do the ceiling function. So remember, don't forget to import math, which we already have. And then what's this doing? Math.ceil, it's saying take the ceiling of 6.5, which is in effect saying, hey, round up 6.5, and you can print it, and it will print out 7. And that's the ceiling function. Now let's quickly talk floor. The good news is that the floor function will go a lot faster, because floor is just the opposite of ceiling. It gives you the largest integer that's less than or equal to the value you put in. Again, that's a mouthful, but practically speaking, you can think of it as a request to always round down. Okay, so instead of math.ceil, it's math.floor. And math.floor of 8.9, for example. Remember the parentheses this time, and it will give you 8. Okay, even though 8.9, I mean, 8.9999999, it doesn't matter how close you get to 9, it's always going to bring it down to the next integer, it's going to give you 8. And then, of course, math.floor 8.1 is also going to give you 8. Okay, what about just for do something a little crazy? What about 0.000? Whoops, 0.0001. What's that gonna do? One of these days I'll remember all these parentheses. Okay, and that brings you down to 0. All right. What if it was the ceiling? Brings you up to 1. And so you see, it doesn't matter how close you get to the other, it's instructing the computer bring it up or bring it down. All right. And as for negative numbers, well, let's remember our number line that we still have up here. And this time it's going to give you the number of lesser value. So it's the opposite of ceiling. So hopefully you remember if we do, say negative 2.8, is this going to give you, oh, now where's negative 2.8? It's right around here. Is this going to give you a negative 3 or a negative 2? Gives you the negative 2. So, that's because it's ceiling, not floor, which makes sense. I was very confused there for a second. I was thinking, why in the world? But of course, it's because we had math.ceiling up. Let's try it again. This time, we're actually doing math.floor. And negative 2.8, it's right there. Is it going to give you negative 3 or a negative 2? Okay, it gives you the negative 3. And that makes sense because remember, we're trending towards negative infinity here, where we're pushing back to the lesser value, which is going to be negative 3. Finally, truncate. To quote unquote truncate your number, what does that mean? Think of it as I want to chop off all the decimals. Okay, so let's take a few examples. Let's do math.trunc, and don't forget to import your math function, which we already have. Math.trunc of, a bunch of decimals after a number. Okay, and so then what happens? It just gives you that integer 4. So you have 4 point all these numbers, chops them all off, and just to show you, print. Let's print the type. And it's an integer. Okay, so that number that we just saw, it is indeed an integer. It truncates all of these numbers and gives you the integer 4. If we wanted to use the constants that come with the math module that we discussed in the previous video, you can do that to some extent as well. So let's see. Actually, we already have math imported, so that's good. Let's do math.trunc, math.pi, and remember that's going to say, hey, take this, pi to 15 digits and truncate it. What's it going to give you? It gives you 3. Okay, or if you want to be fancy and use tau instead of pi, remember tau is 2 times pi. What's it going to give you? It's going to give you 6. Okay, makes sense. Can you truncate infinity? Okay, what do you think? Let's see. Remember that math.inf is our way of representing infinity using the math module. And no, overflow error again. It's too much. You can't truncate infinity, which makes some sense. How could you possibly do that? And same with not a number. It's going to give you an error as well, but just for purposes of showing you, if you do trunc of not a number, it also gives you an error. Can't do it, can't truncate something that's not a number to begin with. Okay, last thing. Let's revisit this rounding up at 0.5 because remember I told you there were 2 things that I would show you to do. One being the ceiling and the other being something a little fancier with truncate. here's a trick you can use using the trunc function to effectively always round up at 0.5, and that's to truncate that number plus 5. What do I mean? Well, I just opened up a new console, so let's import math again. And now let's do math.trunc of 99.4. Let's start with plus 0.5. Okay, what is this really saying? This is saying 99.4 plus 0.5, and then you truncate it. Well, what's 99.4 plus 0.5? Let's start with that. Is of course 99.9. All right. So what happens when we truncate that? It gives us 99. Okay. So this trick that I'm going to show you, uh, it's rounding it down effectively if we're saying this is 99.4. But when we have that 0.5 value, you'll see it actually is rounding it up, and that's actually pretty nice because rounding, it would have rounded 99.4 if we had just done it round. It would have rounded it down to 99, so that's good. And if we do math.trunc of 99.5 plus 0.5, okay, what's this saying? This is saying, hey, take 99.5, add 0.5 to it, then truncate it. Well, 99.5 plus 0.5 is already going to be 100, and so we'll truncate it, and it'll be 100. And so this is kind of a backdoor way of rounding if you think about it, because what if we were doing 99.6 plus 0.5? Well, that's also going to give us 100. That's going to round it up. So this trunc function can be used to round if we take the number we want to round and add 0.5 to it. And it can be used to round in a way that always rounds the 0.5 as up, because all we're really doing is we're adding 0.5 to the value we want to round and then chopping off all the decimals. And so that's a little backdoor way to round in a way that will always give you a higher number at 0.5 if you want to do a rounding in the way that you might be more familiar with in your math class rather than the way that Python does it by default. Okay, so that's it for today's video. Oh, actually, no. One more thing. Let's do a negative number with this truncate rounding trick just to see. Um, in the case of a negative number, remember that round function, when it sees 0.5, it says, I'm going to the nearest even integer, right? So say we have round of negative 4.5, and that gives you negative 4, versus round of negative 3.5, and that also gives you negative 4. What's going on here? Let's go back to the number line, right? You know, what it's saying is I'm going to go to the nearest even integer just from rounding. So negative 4.5 is right around here, and the nearest even integer is negative 4. Same with negative 3.5. The nearest even integer is also negative 4. Okay, well, say instead you do this little trick to truncate the value plus 0.5. All right, so math.trunc of negative 3.5 plus 0.5. What's that doing? Well, it's saying negative 3.5 plus 0.5, so in other words, negative 3.0. Truncate that. It's going to give you negative 3. And so you see when you round negative 3.5, it really rounds down. And I say down because remember, it's negative numbers, so it's going towards negative infinity. All right. So the negative 3.5, if you just round it, it rounds down to negative 3. But what if I wanted it to round up instead? you can do negative 3.5 plus 0.5, and that will round it up to the higher value of negative 3. Okay, so that's actually it for today's video, which covered the round function that's built in, as well as a few functions in the math module, math.ceil, math.floor, and math.trunc for a variety of different ways and tricks to round. Thanks very much for watching.